Hello YouTube and welcome to What the Math, and this is the Sun. Or is it the Sun? Because there's another sun flying around the Sun, and that's a terrestrial planet. And today this is our mission. Basically I'm going to show you how you can terraform a star. And this will involve some really awesome theoretical theories of stellar dynamics and also stellar manipulation, which is, there's quite a lot of science fiction books that actually do mention this. But I'm going to do it my own way. I'm going to show you one of the ways that you can actually terraform a star by essentially splitting it into several parts. So as you can see, I have a part of a sun flying around here, another part flying right here, and then a smaller sun, which is a terrestrial planet, orbiting one of the smaller parts. So let's take a look at this from scratch. Alright, so this is our solar system. I'm going to zoom in on the sun. And here, so the challenge is to try to terraform a star. And how do you do this? Well, you can't really do this. Theoretically, it's possible if you maybe get some of the material from the star and then turn this into a terrestrial planet. And this is what I did in the short part I just showed you before. But terraforming a star would involve changing its composition because, this is a huge nuclear reactor. You can't really live in a nuclear reactor. So one thing you can do is obviously start decreasing its mass until it becomes, until it loses its nuclear reaction and becomes a transition state between a star and a gas giant, which you'll see in a second. But as you'll notice, what happens when I start decreasing the mass, all of my planets start flying away because there's just not enough mass for sun to hold them. But let's just continue this. Let's see what happens. So it's currently still a star, and now it's a gas giant called 2007. Oh, that's never mind. It's still called the sun. I'm sorry. I was looking at something else behind it. It's a blue gas giant, very similar to Neptune. And if I keep decreasing this, I can start playing around with materials with various composition until I turn this into a terrestrial planet. I'm going to give it some iron core, remove all of its hydrogen, give it a lot of silicates, a little bit of organics, a little bit of carbon dioxide, and keep decreasing the size until it's small enough to become a terrestrial planet. There you go. So this is a terrestrial planet. It does have a very, very high gravity and basically temperature of near absolute zero because there's really nothing for it to heat it up. And I don't even know where this light is even coming from because there's nothing that way. There's no stars. There's no sun. So essentially, this will be a very, very cold terrestrial planet. Very beautiful though. Look at it. It's so white and white. Really, that's all there is to it. It's just white. Now, to make a terrestrial planet, it needs some kind of a heating system. And this is why I decided to do something different. First of all, if the sun loses mass, everything flies away. Our solar system officially no longer a solar system, and it's just a bunch of planets flying around. So we do need to maintain its sunness. Essentially, it needs to still be a star. Now, how do you keep it a star and then still give it that terrestrial planet-like features? Well, one thing you can do is you can actually try to isolate it into several other stars, several smaller stars. Essentially, you can split sun into several parts, into chunks that will still maintain their mass, meaning that the planets will still be flying around it, and at the same time have little chunks, little pieces, where one of the pieces will actually become a terrestrial planet. Now, how do we do this? Well, theoretically, we can't really do this yet. We can't even speculate about how to do it, but I'm going to do it my own way. I'm going to pretend that we have all these technologies of stellar manipulation. This is like thousands and thousands of years in the future where we've learned how to manipulate stars, not just planets, but also stars. And we're going to take Mercury. Mercury is right here, terrestrial planet that's just a little bit too small for us. It's not really comfortable. We've lived on it for a while, but it's not really prime real estate anymore. So we're just going to take it and turn it into a black hole, and then change its orbit in such a way that this black hole is going to pass through the sun several times, splitting it into chunks. Now, I don't really know if this is actually possible because black hole is a singularity that we don't really know enough about. We do know that if a black hole comes close to a star, and it does have a much higher mass than the star, then usually what will happen, it will actually absorb some of the sun's mass, but we don't really know what's going to happen if it passes through the sun. Chances are it might actually distribute some of the mass into itself, but at the same time it might not actually do anything. I'm going to assume that black holes do have some kind of a feature that will make them sort of like little needles piercing through the sun. And if we do this enough times, we can actually try to split sun into several parts. And what I'm trying to create here is something like this. There's a feature in this game called choreography, I think. It's called choreo. And this is basically various stellar bodies flying around each other in a very specific manner. Now, we're trying to split our sun in about 10 pieces, or even 11 pieces, and essentially create something like this, actually. Let me just show it to you. This is moons, so let's just do it with suns. We're trying to create something that looks like this. Or not even like this, maybe even something different. So here, a bunch of stars flying around each other. Uh-oh, that's not good. Okay, that's because the simulation is not perfect. Let's see if I can find another one where it's a little bit more stable. Because here, basically what happens is, as soon as two stars collapse, or collide with each other, they will create a supernova. So I have to try to avoid this. I'm going to try to see if this is a little bit more stable. Alright, so this is actually even more pretty. And here what happens is we split sun into 6 different pieces. And these pieces form this specific pattern. And this is like basically the epithet of stellar manipulation, where not only can you split a sun, but you can arrange it in specific shapes and patterns where they... Oh no, that's not good. Well, okay, that wasn't supposed to happen, but they'd be supposed to be orbiting in this pattern forever and ever, and here comes another supernova. Alright, let me find something more stable. Actually, I think I found one that was really stable, that never actually crashes into each other, and it was with 3 bodies. This is just a simulation of 3 bodies. So here, let's assume that this is what's happening. All these suns were split into 3 parts. I'm sure you can do it with some other parts. I don't really want to go through each of the choreography thingies to find the specific one that works. But this one is very stable. So here, this will be basically forever. And the mass is still inside, so the mass of sun is maintained. And the planets that were flying around it will probably still be flying around it, just with a slightly different shift in their orbit. And these pieces of sun will be orbiting around each other. Now, that's not enough for us. What we're going to do is, we're actually going to add a little bit to them. We're going to introduce terrestrial planet, let's just say Earth in this case, around each of them and see what happens. So I'm going to put an Earth right here, Earth right here, and an Earth right here. Now, because this is an actual sun and the Earth is really close to it, it will most likely not become a terrestrial planet. It will just become some kind of a dry, super hot rock. But they will still be orbiting around these 3 suns without really changing anyone's orbit or anyone's direction. So as you can see, as they keep flying around these 3 suns, they will not really affect anything. I think I put too many planets here. I'm going to remove one just to make it a little bit faster, because my simulation suddenly slowed down. It's actually very, very slow now. But just start with one Earth for now. So here we go. Here's the planet orbiting around the sun, and as you can see, it does not affect the orbiting direction of any other body in this particular system. So we can actually do this without really worrying about disturbing the orbit of these sun pieces. So okay, so that's step 1. So no, that's step 2. Step 1 is basically create a black hole that can kind of split sun into several pieces, specifically maybe 10 pieces or so. And I'll show you why I mean 10. If we look at a star similar to a sun, I'm going to start a new simulation right here. There are 2 stars specifically I'm actually interested in. There's one called Proxima Centauri, which is actually relatively close to us, which is about 1/8 of the sun. And there's another one called Bernard star that's about the same. And there's another one that's called EV Lacerta, and this is the one I actually want to use. It's about 1/4 of a sun. So basically this means splitting sun into 4 pieces. And what this star is interested in, what is really interesting about this star is that I can actually put a terrestrial planet very close to it, and it will maintain its terrestrialness. Let me show you what I mean by this. I'm going to put, just for fun, let's just make this a binary system. I'm going to put one right here, and then one more right here, and they're basically going to be orbiting around each other in this fashion. So here they are flying around. Just to make this a little bit more accurate, I can actually put 2 more in there. And this will create a kind of a binary within the binary. So this is like a tertiary solar system. And essentially this, oh, that's not good. Oh, that's not good. That's not what I wanted. Okay, they kind of did things their own way. This because I actually did not make this perfectly. I really have to, or we in the future will have to make this really precise. The barycenter, or basically the center between two stars, has to be very specifically located, and these stars will have to be placed in a very specific manner. So let me just try this again. Alright, let's hope this works. It's still very rough, but I hope this works. So I'm trying to create a tertiary solar system here with two stars orbiting around each other, and then these two pairs orbiting around each other as well. So, okay, this is not perfect, but it's probably as good as I can do it roughly without really using very specific math. Normally this would be a circle, not whatever shape this is. But essentially this is it. This is actually, in total, this has a mass just a little bit over the mass of Sun. And these four stars represent Sun that has been split into, okay. I'm just gonna use two. And this basically represents a system that has a similar mass to the Sun. Alright, I'm just gonna choose two because I know this actually works with two really well. And here we go. So this is a binary system, a human-made binary system, where they essentially orbit around each other in a perfect circle. And there's a barycenter somewhere right here, and you can actually put a planet right there as well. I'll show you in a second what I mean by this, because this can be another type of a solar system where when we reach the ability to manipulate stars, we can actually create some pretty awesome shapes. But this is the one we're actually interested in right now, because what will happen is if I actually put a little piece of Sun orbiting around it, and it's a piece that's, that contains a lot of silicates, a lot of iron, things that basically are present in our Sun. We just have to try to separate them from the Sun. What will happen is you'll create a perfectly, not perfectly, but relatively good looking binary solar system with terrestrial planets. And I'll do this right now. Okay, so let's take a look at what I've just created. So we have two suns orbiting around each other. Then we have these two planets called Sun Terra 1 and Sun Terra 2 orbiting around each of the suns, and none of them seem to be influencing each other. So there's actually quite a really nicely balanced solar system. So let's take a look at what we have for each of these. This is Sun Terra 1. I'm going to zoom in on it in 1 second. And this is what it looks like. It's a very beautiful planet. Spins pretty fast, has water, has really nice temperature of 39 degrees Celsius, and everything else is there. There's life, there's, you have water, you have iron, you have organics, carbon dioxide, and even though it is pretty close to the Sun, it doesn't actually affect it as much, because the Sun here is a lot less powerful than our actual Sun, because once you split this, or once you split the star into several pieces, it won't actually have as much luminosity and as much energy. So these tiny pieces are a lot less powerful than our entire Sun together. One interesting thing about this particular terrestrial planet is that its orbital period is only 8 days. In other words, its year is actually faster than its day. The other thing is that because there are two suns here, you can see that there's very interesting night cycle here. So the night cycle is shaped like a piece of watermelon, actually. So right here you can see the night is actually kind of slowly increasing. I mean, the slice is actually increasing, covering about half the planet. But for the rest of the time, right here, it's actually decreasing, and most of the planet will be covered in complete light. So it's a very interesting kind of dynamic. So if we do find a binary solar system with terrestrial planets out there somewhere in space, or basically any kind of a planet, it will probably have a very similar effect. So this is a really awesome night effect, and this happens very periodically. It doesn't happen every year, but it happens approximately. Let's just actually count how often this happens. So let me just pause this for a second. So basically, when the planet is away from the other sun, it's actually on this side. This is when you get the full night cycle on the other half of the planet. But as soon as it actually moves around this star, as soon as it basically approaches this area, this is when it will have a very interesting half a night, and then it will have almost no night whatsoever. So basically, this is a full day planet. And they're both actually going to be like this, and this will happen every half a year, or essentially every 4 days. So every 4 days you have no night, and then it actually kind of splits, and then it goes to the other side. So this is Sun Terra 1, and then Sun Terra 2 is very similar. I decided to actually give it a little bit less mass. It's actually very similar to a planet like Mars, and it looks a little bit different. Does have a slightly shorter day cycle, so it doesn't spin as fast. So if, for people that don't like to have a spinny planet, this is a planet to choose. But at the same time, it does still have the same kind of a watermelon-like night cycle. So both of these planets are basically daylight planets. And the thing is, we can actually put as many planets here as we want. We can actually have a binary system of planets orbiting around the sun. And, you know, if we can split the sun, I'm sure we can actually try to place as many planets around this system as we can, creating some really awesome patterns. This is basically the pinnacle of human technology, where we are able to manipulate stars, we can actually manipulate black holes, and we create some pretty awesome solar systems. This one is very simple, but some of the ones that are provided in the game under choreography are actually pretty advanced. So let's take a look at some of them. So, for example, this one here only has 3 bodies as well. And this is how they spin around each other. But imagine being able to manipulate stars, splitting them up and creating these beautiful shapes. Okay, I got a supernova again. But I'm kind of getting off track here. The idea here is that once we reach the kind of a level of technology where we can manipulate stars and create various things, within the stars, we can create something like this. We can create some of these awesome shapes, and some of these are actually pretty original. Unfortunately, not all of them are stable enough. I think mostly because here we go with supernova again. Unfortunately, this happens because the accuracy of this simulation is not exactly 100%. Oh boy, this is a lot of supernovas. Yeah. My computer is about to die because of just a bunch of objects. I think there's like 11 objects collided with each other. So let's just go to a different one. Let's go to this one here. And some of these are actually pretty amazing. I'm going to use moons because moons will not cause supernovas. And some of these shapes are really awesome. So, and this is basically the pinnacle of human technology. If we can do this and then create patterns and then have various planets orbiting around these stars. Oh boy, this is not stable again. Around these planets, around these stars, we can create any kind of a shape, any kind of a solar system, and have some beautiful patterns in the sky. Wow, that's actually quite beautiful as well. But what I'm really excited about is this game allows you to manipulate all this. It allows you to play around with a lot of these other features, and essentially create any kind of a solar system you want. So actually. Anyway, I'm going to pause this here. So basically the summary of all of this is that if you want to try to terraform a star, you need to split it first. You need to split it into several parts, and then use one of the little parts that you split it from to create a terrestrial planet. And then you can use that to manipulate various features to essentially create a habitable planet where we can live as a species. Hopefully this was helpful, and do play around with some of these simulations here, some of them pretty awesome. Before I finish, I actually wanted to show you another simulation this game has, and this is actually when you have Earth in the middle of 2 stars. So it's a simulation right here. It's called Earth in between 2 suns, and essentially it's what it sounds like. There's a sun right there, and there's another sun on the opposite side right there. If you look from the top, this is what it looks like. Both of these suns are actually equidistant, and Earth lies in the very center, essentially right in the middle of the circle. If you are able to place it directly right there, it will stay there forever. And these suns do not orbit around Earth; they're actually orbiting around each other. So this is a binary system. If I accelerate time, I'll show you what I mean by this. They're orbiting in a nearly circular orbit around each other. Now this is a very kind of a Earth-centric system, similar to the ones that we used to believe in back in the Dark Ages, in the medieval times. People thought that Sun orbits around Earth, and in this case, they're actually right. It is. But look at that. There's actually a very tiny piece of night. There's almost no night on this planet. This is a planet of constant daylight, so there's never any night on it. For human beings, it's actually it will take quite a lot of time to adapt to this kind of a system, because we do need night for our bodily functions. But the other thing is that because there are two suns, it's actually going to be much warmer here. It's actually almost double of the temperature on Earth. It's around 67 degrees Celsius. Essentially, it's really, really hot. So I don't think we would actually like to live here unless we separate the suns a little bit further away from each other, in which case the temperature will decrease. Anyway, so this is another way of creating this kind of manipulated solar system where you can split these two suns into several pieces, have them orbit around each other, and right in the middle you'll have another piece of the sun that will be the planet where we can live on. Okay, so thank you for watching. This has been What the Math, with an attempt of creating a terrestrial planet out of a solar body. Hopefully this was helpful. Hopefully you kind of try this yourself and play around with this and create some new interesting ideas that we can explore together. Thank you for watching. Please subscribe and good luck to you. Bye-bye.